This is the monthly review for semester 4. The subject is chemistry for grade 9. We first learnt about the complete combustion of alkanes and alkenes. The reaction of hydrocarbon with oxygen is called combustion. The product of the complete combustion excess of oxygen or carbon dioxide and water. During combustion, a large amount of heat is released. So this is the general formula for the combustion of alkanes. For example, if we have methane, so the N equals 1, methane is CH4, so N equals 1 is C. H2N plus 2, so that's 2 times 1 plus 2, which is 4. So this is methane, plus 3 times 1 is 3, plus 1 is 4, divided by 2 is 2, O2. Which equals N is 1, remember, so that is CO2, we don't write the 1, plus 1 plus 1 is 2, H2O, plus heat. Okay, so this is how we write the complete combustion of methane. This is the equation for the complete combustion of alkenes. For example, if we have ethene, so N equals 2, so we have ethene is C2H4, C2H4, remember this is ethene, plus 3 times 2 is 6, divided by 2 is 3O2. Remember N equals 2, so that's 2CO2 plus 2H2O plus heat. So this is how we write the complete combustion of alkanes and alkenes. Substitution reaction of methane, which is chlorination. In the presence of sunlight, a mixture of methane and chlorine gas reacts and a hydrogen atom is replaced, substituted with a chlorine atom. So we have methane, CH4 plus Cl2, in the presence of sunlight, reacts to form CH3Cl plus HCl. So I'll show the structural formula for this. We have CH4 plus Cl2, and what will happen? The Cl would be substituted for this H. So effectively we'll have CH3 Cl plus HCl. Remember, this is done in the presence of sunlight. We then take this molecule that we obtained here and we add, so CH3Cl, and we add Cl2 to it to give us CH2Cl2. So this H here, okay, is substituted with one of these Cl's here to give us CH2 Cl2 plus HCl. And then again we use the product here, okay, and we add more Cl2 to it. This Cl from here is then substituted with one of the H's here to give us CHCl3 plus HCl, and again we use the product in the second to last reaction to finally give us CH3Cl3. We add more chlorine to it to give us CCl4 plus HCl. Addition of hydrogen, hydrogenation. An ethane molecule reacts with hydrogen to form a saturated hydrocarbon ethane. This reaction is called hydrogenation. It requires nickel as a catalyst and heat. For example, we've got this molecule, this is ethene, okay, and we add hydrogen to it, H2, in the presence of nickel and heat to give us CH3. I'll draw the structural formula for this. So we have CH2, okay, and CH2, double bond CH2, plus H2. And what will happen is this molecule will come and break this bond here. This H come and attach itself to this carbon, and this H will attach to this carbon. This will give us CH2 here with the addition of the new H. Okay, and then we've got this CH2 here with the addition of another H. So what we'll have effectively is an ethene going to an ethane. Then we learnt about the addition of chlorine, Cl2. An ethene molecule readily reacts with one chlorine molecule to form a chloroethane product. So we have CH2, which is ethene, remember, plus Cl2 will give us CH2Cl, CH2Cl. Draw this out for you again. So we've got CH2, double bond CH2, plus Cl2, and what will happen is this bond will break, one chlorine atom will come attach itself to this carbon, and this chlorine atom will attach itself to this carbon. So effectively what we have is CH2 Cl CH2 with the new Cl. Okay, and this is called, so this effectively is ethene, and this is called 1,2-dichloro ethane. Okay, so this is called 1,2-dichloroethane. So we learnt then about the addition of HCl. A ethene molecule reacts with one hydrogen chloride, which is HCl molecule, to produce chloroethane. For example, we have CH2, remember this is ethene plus HCl equals CH3, CH2Cl. So I'll draw that out for you. So we've got CH2 plus HCl. What will happen is this bond will break. This hydrogen will attach itself to this carbon, and this Cl will attach itself to this carbon. So what we will have is CH2, okay, and another H, another C, H, and remember to this carbon we have attached to it a Cl. So we here have ethene, and this is now called chloroethane. Chloroethane. Addition of water, H2O, which is hydration. An ethene molecule reacts with a molecule of water to form an alcohol called ethanol. This reaction is called hydration. It requires H2SO4, which is sulfuric acid, as a catalyst and heat. For example, CH2 double bond CH2, which is, remember, ethene. plus H2O, which is water, equals CH3, CH2, OH. Anything that ends with OH is an alcohol. So let me draw this out for you. So we've got CH2, double bond CH2, plus H2O. Okay, and what will happen is this bond will break, the hydrogen will come and attach itself here, the OH will attach itself here. What will we have? Remember, this needs H2SO4, which is sulfuric acid, and heat. We need to write it up here as well, H2SO4 and heat. So what will happen? So we'll have CH2 and then another H was added from the water. Then we have another CH2 and an OH is added from the water. Okay, remember OH means it's an alcohol. And how do we name alcohols? So you know this is a ethane molecule because it has two carbons, so it's ethane. Remove the E and we put OL, so it's ethanol. Okay, so this molecule is called ethanol, and this is called ethene. Now we'll do the questions on the exam review. Question 1 says, PVC is one of the most used plastics in the world. Here we've got the number of protons, and here we've got the mass number. This is document 1. Document 2 looks like we've got a chloroethene molecule. So question 1 says, document 1, which is here, copied and pasted it for you, shows the atomic composition of the vinyl chloride molecule, so it's the PVC. Recopy and complete the adjacent table. Okay. So first we have the number of neutrons and hydrogen. So remember, N equals A, which is mass number, minus Z, which is proton number. So we have A, which is 1, minus Z. Z is the number of protons. So here it's 1. We can see here it's 1 around here, which is in the middle, which is 1. 1 minus 1, which equals 0. For carbon, we do exactly the same. So N equals A, which is 12, minus. Here you can see the number of protons is 6. So 12 minus 6 is 6. And here N equals 35. Remember, we look at the mass number, which is here, minus 17, which equals 18. Then we have to write the electron configuration. Now they've given us the number of protons, so we're going to write here in a neutral atom number of protons equals number of electrons. Okay, so we've got H1, number of protons for hydrogen is 1, so we write K1. For carbon, we've got the number of protons is 6, so the number of electrons must be 6, because in a neutral atom, number of protons equals number of electrons. So remember, K can hold a maximum of 2 electrons, so it's K2, and then L 4. 4 plus 2 is 6. And then we have chlorine, which is 17. Here is 17. So K can hold a maximum of 2 electrons. L can hold a maximum of 8 electrons. So that was now 8 plus 2, it's 10. But we need 17. So then we'll go to the next energy level, which is M. So we've got 8 plus 2 and we need 7 more. K2, L8, M7. Then it says write the Lewis dot symbol for the carbon atom. So the carbon atom, we look at the Lewis dot symbol shows the chemical symbol with the electrons in the last energy shell. So as we can see here, in the last energy shell, carbon has 4 electrons. So you write carbon with 4 electrons surrounding it. And this is how we write the Lewis dot symbol for the carbon atom. Then it says, knowing that the relative charge of an electron is -1, the relative charge of an electron cloud of carbon atom is. So what is how do we work that out? So the charge of the electron cloud is the number of electrons times charge of 1 electron. Now we know that the number of electrons from the previous slide for carbon is 6 times by, here it's the charge of an electron is -1 times by -1, remember in brackets, which equals -6, so therefore it's -6. The valence of carbon atom is, remember we looked, the valence is how many electrons it has in the last energy shell, and we said that that was 4. Remember we drew the Lewis dot structure like this, and there is 4 electrons in its last energy shell. Document 2 shows the molecular model of the vinyl chloride compound. Give the molecular formula of this compound. So we have 2 carbons here, so it's C2. We have 3 hydrogens, so it's H3, and 1 Cl. Here you can see we've got 1 Cl. So it's C2H3, Cl. Specify the type of bond between 2 carbon atoms. So you know that the carbon atoms is in group 4 because it has 4 valence electrons. Okay, so we know that this is going to form covalent bonding because both of them are non-metals. And there's 2 bonds, as you can see right here, 1, 2. So it's a double because there's 2 covalent bond. Sulfur burns with oxygen gas of the air according to the following equation: S plus O2 equals SO2. Calculate the oxidation number of S in SO2. So the oxidation number of S plus 2 of the oxidation number of oxygen equals, remember, 0. Now we want the oxidation number of X, so this is the oxidation number of S equals -2 of the oxidation number of oxygen. So we know that the oxidation number of oxygen is -2. This you should know. So -2 times by -2 is +4. Okay, so the oxidation number of sulfur is +4. So sulfur oxidation number of sulfur equals +4. Show that the above reaction is an oxidation reduction reaction. So we have here S plus O2 is SO2. Remember, oxidation of sulfur, an atom by itself, is 0. O2 is also 0. Here we said it was +4, we just calculated it. And here it's for oxygen is -2. Remember here, so from S2 0 to +4, we have lost electrons. So therefore the oxidation number has increased. Okay, so this is oxidation, because oxidation is the loss of electrons. And then from here to here, from oxygen went from 0 to -2. So this shows that the oxidation number has decreased. So therefore reduction, because reduction is the gain of electrons. So since the oxidation number for sulfur has increased from 0 to +4, oxidation took place. And the oxidation number for oxygen has decreased from 0 to -2. Therefore reduction took place. Oxidation and reduction happened in the same time, therefore oxidation and reduction happened at the same time. Therefore, redox reaction. Question 3 says specify the oxidizing species. So this is the O2, because it's capable or because it's gained electrons. So specify, we have to justify. Magnesium, 12 Mg, is a lightweight and relatively soft metal that strongly reacts with oxygen gas found in the air when it is heated. The chemical reaction is represented by the following equation. The intense light produced during the combustion of magnesium leads it to be a widely used in photographic flashes. Pick up from the text the reason why magnesium is used in photographic flashes. So the intense light produced, I'm going to use this one here, light produced during the combustion of magnesium is the reason why magnesium is used in photographic flashes. Write the electron configuration of the magnesium atom. Here it says referring to document 1. So magnesium, the atomic number, which is the number of protons of magnesium element, is equal to 12. Remember, in a neutral atom, the number of protons equals to the number of electrons. So here we have 12. So remember, the first energy shell is K. You can fit 2 electrons. And then it's L, which can hold a maximum of 8 electrons. We still have 2 more because we've got 10. And then we go to the next energy shell, which is M. That can fit 8 electrons, but we only need 2. So it's K2, L8, M2. So here, if we add all of these numbers, give us 12. Deduce the column and the row to which magnesium element belongs in the periodic table. Now, so magnesium has 3 energy shells, or levels, which are K, L, M. Therefore, it's in equals to row 3, and MG has 2. See here, because it's got the last 2 valence electrons, so therefore it's in column 2. So it's in row 3, column 2. It says deduce. So we have to look at the information that's above. So here it says recopy and complete the following table. So we know that the number of protons in magnesium, which was given above, is 12. Okay, so that the number of protons in magnesium, which was given in the previous slide, was 12. So atomic number for all magnesiums is not going to change, especially for isotopes, because in isotopes it's the number of neutrons that change and it's not the number of electrons. So here it's 12. The mass number is given above here, so here's 24, here it's 25, and here it's 26. The number of neutrons, remember we said N, so it's the number of neutrons, is A, which is the mass number, minus Z, which is the proton number. So here we have 24 minus 12, which equals 12. Here we have 25 minus 12, which is 13. And here we have 26 minus 12, which equals 14. Then it says determine the relative nuclear charge of the magnesium atom, knowing that the relative charge of a proton equals plus 1. So we know that the charge of the nucleus says relative nuclear charge, so we want the nucleus of the nucleus is the number of protons times charge of 1 proton. Remember, the nucleus has protons and neutrons, so plus number of neutrons times charge of 1 neutron. Now, the neutrons don't have a charge, so we can put a line through it and put 0. Now we know that the number of protons is 12 times the charge of 1 proton is given to us as plus 1, so it's 12 times plus 1 in brackets, so that equals plus 12. So the charge of a proton is plus 12. The nuclear charge of the magnesium atom is plus 12. Question 3 is about the galvanic cell. It says give the name of each of the 3 numbered components and then set up A and B. Okay, so here's number 1. So here we have Cu, so the solution must be Cu2 plus. Okay, here we've got number 2. Here we've got a magnesium strip, so the solution must be Mg2 plus. And then we've got number 3 is here. Okay, and then we've got, just because we've got in the solution zinc 2 plus, so the metal here must be a zinc strip. So we can just write zinc. Okay. So question 2 says the voltmeter in the setup D indicates 0 volt reading. Explain why. As you can see here, all of them have salt bridges, so this is called a salt bridge, except of D. So in D there is no salt bridge. Therefore, there are no ions to neutralize the solutions. Okay, and therefore the reaction will stop. Okay, so we won't have a transfer of electrons. The reaction will stop. Referring to the setup C, specify the anode and the cathode for the galvanic cell. Remember, the anode is the electrode where the oxidation reaction takes place. Oxidation is the loss of electrons. So remember oil rig. Oxidation is the loss of reaction, and cathode is the electrode where the reduction reaction takes place, and reduction is the gain of electrons. Okay, so we'll look at C. Remember, look, the electrons are going this way. Okay, the electrons are going this way. So here Mg is losing electrons. Okay, so it's the loss of the electrons, so therefore oxidation, so therefore this is the anode. Cu is gaining the electrons, therefore where reduction is taking place, so this definitely is the cathode. So here we write Mg is the anode. They're specified, so we have to justify. So Mg is the anode because this is where oxidation is taking place. Remember, oxidation is the loss of electrons. And Cu is the cathode because this is where reduction is taking place. Should hear this as well. Okay, indicate which of the following representations correspond to the galvanic cell of the setup C. Remember, we always write the anode, then the cathode. So this is the anode, then the cathode, so this can be a right option. This is also written as anode, then the cathode. That could be the right one as well. However, the last one, they've written the cathode, then the anode, so this is definitely wrong. So how do we write the representation? So Mg went from Mg to Mg2+, right? Because it has lost the electrons. But Cu2+, it gains 2 electrons to become Cu. Okay, so it's this one. Okay, so this one is the correct answer because it shows the correct representation. Okay, the Cu does not become Cu2+. The Cu2+ gains 2 electrons from the magnesium to become Cu. So the first one is the correct representation. And then it says, write the equation for the half reactions. So Mg. Okay. We first had magnesium. This became Mg2+, and it lost 2 electrons. So this is the oxidation half reaction, and then we have Cu2+ plus 2 electrons that we got from the magnesium to become Cu. So this is the reduction half equation. So to deduce the overall reaction, remember what we do is just copy them as they are, just so we have the information in front of us. Okay, remember we cancel out the electrons. Okay, so plus 2 electrons from here, 2 electrons from here, and then we write everything from the left of the equation first. So we write Mg plus, so here we've got Mg and Cu2+ on the left of the equation, of the arrow, Mg plus Cu2+, and we write an arrow which gives us Mg2+ and Cu. So Mg2+ plus Cu. Okay, and this is the overall reaction. The table below shows the number of carbon and hydrogen atoms in two structural hydrocarbons A and B. Define hydrocarbon. These are made. So the clue is in the name: hydro, hydrogen, and carbon. So these are made of carbon and hydrogen atoms only. Then says write the molecular formula of A and B. So we've got here A and we've got here B. A has 4 carbons, so we write C4, and 10 hydrogens. B has 2 carbons and 4 hydrogens. Now, this is for your information only. I don't want you to write this in the exam. So carbon 4, C4H10, looks like this as a structural formula. This is an alkane. Okay, this is an alkane. This B is C2H4, so C2H4, and that's an alkene. Okay, this is a alkene, C2H4. Then it says give the IUPAC name of each of the following compounds. So first look at the longest chain. As you can see here, this is the longest chain. Okay, so it's got 3 carbons, so it's going to end with propane. And on the second carbon, so if we number them 1, 2, 3, this 1, 2, 3, both is on the second carbon. So number A is 2 because the methyl group is in 2. 2 is on 2. It's 2 methyl propane. B, also take the longest chain, which is here. Okay, if we count, starting from here, 1, 2, 3. Here it's 1, 2, 3. And here 1, 2, 3. The most branched is the one in the middle, and it's also the longest chain, so we take the one in the middle. You can see now number from left to right and right to left. Both are on carbon 2, so the 2 methyl groups are on carbon 2. So we write for B 2, 2. Remember comma between numbers, 2, 2 dimethyl, because we've got 2 methyl groups, 2, 2 dimethyl propane. Then for letter C, or for number 3, so we look at the longest chain. Longest chain is here. It's got 5 carbons, 1, 2, 3, 4, 5. 5 carbons. That's going to end in pentane. Okay, there are 2 methyl groups attached to carbon number 3, so it's 3, 3 dimethyl pentane.